Hello, everyone. Good afternoon. Welcome. I hope the Azure Dev Summit has been great so far. We'll talk about, well, let's not go too fast, about DevContainers. So just to get a bit of feel of the room, who has been working with DevContainers already? Okay, that's just a few hands, which is okay. Who considers themselves working as a cloud platform engineer or a cloud engineer? A few hands. Are the rest of you all developers? I see nods. Okay, so there's something for everyone. I'll try to keep up the pace. So we cover the basics of DevContainers, but just briefly, then see how we can use it for environments, such as programming or working with Azure, and then some extra technical details. So bear with me. I'll try to keep up the pace. If I go too fast, just raise your hand, and I'll break. All right, so Azure. When I submitted the title from DevContainers for Cloud Platform Engineers, I didn't really think about it too long. What is a cloud platform engineer? But it could be many things, right? So you could be working on deploying entire environments for your organization. That could be it. But I usually encounter people that work on building a platform in the cloud so others can start using it, a team that is an enabler, especially if teams need to be self-service in their provisioning of the cloud resources. It might be that you're just into the networking side of things, or it could be that you are concerned with how do we get the workloads there on Azure, but we need Azure stuff to run our applications. And that also might mean, and apparently there's quite a few of you who do DevOps. And again, this is a term that is very broad, but to me it's I develop it and I run it, so I operate it. So that's kind of, I need to be able to program my code, but also use the cloud as a way of running those applications that I build. And I want to do both. And I want to, have a tight connection with cloud. So this is you, and this session is about how can we open up Azure so we can have a development environment that is tailored to working in the cloud, and that is specifically bound to that setup, that situation that you have. And it's not just about you, it's also about your other team members, and maybe even about other teams that you want to enable. So it could be many, many things, but we'll start with how do we get our initial environment set up? So let's focus on that first. So we'll try to set up an environment for working with Azure. And you need a few things, right? You can't just take a bare machine. So I listed a few examples of the things that you might need. And maybe there's other things here that aren't listed that you also use. But I see a lot of people working with Terraform, Bicep, maybe Helm charts. That's what they use, and a lot of command line interfaces. Because if you do things automated and fast, usually you want to have a command line interface. So that's one thing. In a lot of cases, you need supporting tools and frameworks underneath, so some runtimes. Could be that you're using Python tooling, could be Node with NPM, things that you need for your tools that also need to be installed. And finally, if you do the DevOps way and you automate everything and you treat everything as code, you will probably need places to store the code, also for your environments, the ones that we'll be building, and want to loop that into your automation as well, and produce some artifacts perhaps, and we'll see that later on. All right, so maybe somebody can tell something about how long was the longest it took you to set up your development environment when you got started on a new job or a new project? What was it like? How many days? Let's start there. Who's multiple days? 3 days. Anyone? 3 months. Okay, that's a serious one. That sounds like policies and stuff. But so it can take multiple days. So that's kind of ridiculous, right? And then the next thing is you have it set up and then the tool moves forward. So the documentation is outdated on how to set it up, or you need 2 environments side by side with different versions because it's the old legacy application and the new one. And usually just install everything on your machine. And maybe it's a virtual machine like a remote desktop thing that you get somewhere, but it's usually a lot of work to get it all right. And it differs per team, per application, per version. The other thing is, if you are in a team and you have this set up, everybody has different flavors and different focus. So why does everybody need to have the same setup document? Why can't they have one that's tailored for the person that's doing mostly networking stuff, or mostly doing the resource stuff, or the development in .NET or something? Yeah, and then the collaboration stuff. Yeah, I'm not on a project, but I want to, you asked me to do a pull request review, so I want to run your code just briefly. But first I need to go through 3 months or 3 days of setting things up before I can run your pull request and see what it does. So various reasons to treat everything as code. All right, so we needed a machine that connects to Azure. You can do that. You can do that locally. That works. You've been there. What does that require? Well, we talked about all the tools, frameworks, and all the dependencies that you have on your machine. But what about this? We add container support to our machine. That's your laptop. It can be Docker, it can be Podman. Those are the two predominant things, but it doesn't always have to be Docker, right? So the Podman is a very cool alternative. And then you can run containers. So we can move everything over. Instead of having it in your local machine, we can put it in the container. So the container has all those things, not your machine anymore. So that's your DevContainer, just to make sure that's the thing you develop in. And that container can connect to Azure with all the proper things installed inside a container. And then you need something to connect to that container, because that's, well, it's a container for a reason, right? It's like a black box thing unless you connect to it, which is something that Visual Studio Code can do, but there's other tools that can also do it, and so there's many ways. We'll talk about that in a bit. But if you have Visual Studio Code or another tool, probably you want to have some extensions that enhance the environment. You can have specialized settings, you can have personalized terminals, whatever. You know, you want to tweak your environment. And doing all of the things, the tools, frameworks, and dependencies, if you work with containers, it means you need to specify what is my base image, which image do I use? Maybe you build it yourself with a Docker file, and you want to add additional features like CLIs and Python tooling, and maybe even the Python runtime. And for the hosting, you host a container, so it needs to be viewable, right? It needs to open up ports, it has its own settings and life cycle. All those things you need to take care of. So it sounds like a lot, but the good news is that we can put the middle and the right hand of the application, of the container, we can put that into a definition, a code file, just JSON file that contains everything that is up there. And the good part is that you can even take your definition of your tooling and put that into the same file as well. And this is what DevContainers is about. Building this definition, and it's not very complicated, and you need to spend some time there, but once you have it, you have your environment in code, not a Word document that says how to do it, but a thing that your machine can spin up and give you this environment with everything installed, all your settings, all your extensions, the features, and the preferred image, so the stuff that you need is there. And you can put it in your repository, and it moves with your code base. Now this is a specification. It started originally at Microsoft, but it's now open sourced. You can go to the website containers.dev, and this website tells you all about the format of this JSON file that says it all, and what should be expected and how tools should implement that. But it's also an entry point to getting templates and features. We'll talk about those as well. Now, we have a container, we have a specification, we can spin it up. You need some things there to work with the Docker or Podman CLI. But you can connect with Visual Studio to many remote things. So there's a bunch of things like SSH to Linux machines, tunnels. If you do dev tunnels, for example, those are really nice. You can connect to your Windows subsystem for Linux and to DevContainers. This is a extension package that exists that's called remote development. It contains all four. So if you point to that one as an extension, you get this remote explorer. And the remote explorer allows you to discover all of those things. Well, that's not all, because if you install additional extensions, for example, code spaces from GitHub, repositories, or Azure repos, it allows you to connect to those as well. So it's your entry point, and maybe you've discovered it. It's in the bottom left corner, so I need to point to the right, of your Visual Studio Code. The little blue box, if you connect there, that's the Remote Explorer that shows you these options. It will use the DevContainer CLI underneath. If you do code spaces, and we'll be doing that, it will use the GitHub CLI, and then you can use Visual Studio Code to connect to all of these. But apparently, or obviously, we're interested in connecting to DevContainers today. So let's focus on that. Do I need to have Visual Studio Code? You might think so. I'm wearing the T-shirt. You know, I like Visual Studio Code, but you don't. If you want IntelliJ or Rider or even NeoVim, you can do those as well. NeoVim is a special one because it's hosted from inside the container, and you have this textual editor inside of your terminal. But the other tools are equally valid if you want to use DevContainers. So I don't think you must use Visual Studio Code. Each of the other ones are applicable as well. All right, so let's go to our first demo. So I have Visual Studio Code here. It's a bit zoomed in. Is it okay in the back? Yeah. You might see that there's hardly any extensions installed in Visual Studio. It's pretty clean because I don't want to install everything already. It should be part of this DevContainer thing. So I'll open up this Azure DevContainers demo that I have. It's based on a sample. The to-do samples with a Cosmos DB running in Azure with an app service hosting an API, with an app service hosting a Node-based React front end, and it's all connected with key vaults and pretty fancy setup. All right, so if we open up a terminal here, this is my local PowerShell. If I do AZ, it doesn't know it. EZD for Azure Developer CLI, it's not there. GitHub's not there, so nothing is installed on my local machine just yet. So do I have .NET? Well, I have .NET. I have a few installed, but that's the local install. I also do local development, obviously, right? And since part of the application is .NET, I thought I'd show you, but see how it has 8, 9, 10, and 2 versions of 10. That's locally. So just to show later on that we're inside of the container, things change around. Now the idea is that you create a special folder called DevContainer, and inside of it you place this main file, that's the DevContainer JSON. And it specifies the image of the container to use. And we'll talk about this for a bit later on, but this is not an Alpine or Ubuntu, but it is something, and this underwater, it has a base image that leans on, I believe, Debian in this case. But you can specify which one you want to use. And this is the other thing to pay attention to now. I add features to this container. So these will be added on top of the base image, Node, Azure Developer CLI, the regular Azure CLI and the GitHub CLI. And I also specified a particular version for Azure Developer CLI. So I kind of tweaked the features. We won't be looking at the customizations except for this part where it says, these are the extensions that I want to have as well. And with this basic setup, I can get started. I did want to show you one last thing. So extensions, there are some extensions installed. It has some recommendations. But also there's no MCP servers. I'm pretty sure you've ran into MCP servers, new cool thing. So I decided let's put that in because you can do that from DevContainers as well. So no MCP servers just yet. Now when I go here and it already detected that I have this folder .devcontainer with a DevContainer JSON. And I can say reopening container. So I will be spinning this up inside of a container. So let's see what happens. Oh, I think it switched because cooking, this is the cake that is finished, right? So let's go here. This is the dev container that's already opened. In the bottom here, so let me zoom in a bit, you can now see that it says dev container Azure Developer CLI. So I'm now connected to this dev container. So all of a sudden, if I go to the terminal window and I open a new terminal window, I can do Z shell, bash, or PowerShell. So if I do a new bash window, I have AZ. Takes a while. I can see which Azure Developer CLI environments that I have. So it says I have two. There's a Azure Dev Summit demo here, and I can do AZD and show, which will show me the default environment, I think. Oh, sorry, AZD show. And it will work. So don't worry about if you understand Azure Developer CLI, that's not what this is about, but I had nothing, and now all of a sudden I have all these tools. If I go to some of the infra things, so this is the Azure Dev Summit, right? So I have a main bicep, and all of a sudden, it knows bicep. I didn't show it before, but then it would just be black, so no support for bicep. But that's all because in this DevContainer JSON, I had the customizations. We had this VS Code bicep extension. And all of a sudden, on the side here, I have all these other things as well. So the Azure AI Foundry, Azure, GitHub Actions. So there's a lot of extensions showing up just by opening this as a dev container. All right. The other thing that you can do is you can start up things. So I believe that up here, it shows you all the things that you can do with the Azure Developer CLI. And let's see, yeah, we can go to one of these. It's kind of hard to see it zoomed in like that, but it allows you to do AZD up, spin up an environment, and then all of a sudden it starts working with bicep, and it starts provisioning all these resources inside of Azure. So I'm creating this application, creating the resources, and also deploying it to it. And if I do AZD show, then I see that I have an actual environment, and I could go to this web environment. And now I have this application running, which is kind of this thing. Let me zoom in a little bit. All these resources were created there, and the application allows me to create a to-do list. So this is all good. We went from nothing to being able to do these kind of things. And this is bicep, and it's certain tooling. It puts you in a good place to work with Azure. All right. So with that, let's dive a little deeper. All right, so we did all these things just by having this definition file. And we created all the resources. Thanks to Azure Developer CLI, it's a choice if you use it or not. But what happened underneath? So we picked a certain image, that was the .NET one, because one of the elements in the application was a .NET backend web API. But you can start from a base image that is provided by someone else, for example, by Microsoft. So they have Alpine, Debian, and Ubuntu base images, and you can pick your version. And they come preloaded with certain tooling. An important one is Git, is already put in there. So it's not the leanest, meanest thing anymore, but it's a small image nevertheless. You can pick whichever version you want to have. So depending on what you need in your application, you can go for an older distro or an older version of the tools that might be installed. So you just pick your semantic version name, and stuff is in there. You saw the Z shell that was installed, and there's also a non-root user installed. So you don't run as root, but you run as this user called VS Code. It might be Node if you pick a base image that is for NPM development and Node development, or it could be CodeSpace if you're running in CodeSpace. But you can say, I need to run as root, and that's also an option. And you can just specify that in your DevContainer JSON. But this is, if you want to build your own environment, you should start by asking, how do I do that? How do I get from 0 to everybody can use this, including myself? Well, the hard way, and this is not what you'll be doing, is you'll start with Alpine or Ubuntu, just bare image, spin that up and start doing apt update, apt install, and installing all the things and curling into install scripts and build it up all by yourself. Don't do it, it's just too much work. The other thing is take a custom image and define it inside of your Docker file. And so make it repeatable instead of doing it manually. So that works a little bit better. But probably you want to use those base images. And we saw the base images that had just the bare essentials, but there are more specialized ones that take it a step further and give you Node, Python, Rust, Ruby, or .NET, or whatever it is you need. It's mainly developer focus, but then again, it's DevContainers, right? But if you have a base image, you can obviously specify a custom Docker file and say, I want to start with the base image that I picked in 3, so one that is for .NET, but I want to do some additional things while building the image. And then you just do from, and then specify the base image, the .NET 8.0 and then from there add some additional things that you add at the Docker file level. And the last one, we'll talk about that later on, is you can even use Docker Compose, which means you don't have one container, but you have a bunch of containers working together for your entire solution. So this is the first choice you have to make, which base image is best. If it's focused and targeted, in this case 8.0.NET, legacy application, you can use that one. If you don't have a particular thing, just go for Alpine or Ubuntu or Debian. And then you do all these things, you'll discover a lot of features that already exist of people that have created install scripts that add these features to your container. So I mentioned, for example, Terraform, if you need Terraform, and you can specify which versions you want to have. So this is the version of the feature, but the feature allows you to define options. And the options can specify which version of Terraform do you want to use. And if you are into Helm and you want to do chart testing, there's somebody that put effort in creating a reusable feature so everybody can lean on that, and it's public. So it's a composable unit of functionality. You just add them together. You can specify in which order they should depend on each other. So one might lean on the other, and you can say installs after, and that's the order of installation. But in the end, it's a script that runs in a single layer on top of the image that you're building. So it's a single layer script. Do your stuff and get rid of your stuff to keep the image layer clean, especially if you're pulling in a lot of NPM packages or updating the packages list, get rid of those. There's plenty of samples that show you how to do that nicely. And it's just too huge a list of all the things that already exist, and you can build your own as well. So you can add your own features, and you can even have them locally in your repository. And this is the site that I mentioned, Containers Dev. The thing, if you are composing your solution, is that you want to go to this thing called available features or available templates. And the available features, let me quickly show you. Let's go to containers.dev, available features. So wild guess, right? So this is scary, but this is non-scripted. But is there something you missed as a tool or a thing that you're like, I'm using this very often? Sorry? I heard CLI, but let's just do CLI. I'm not sure if it's there, but you know, there's a lot of CLIs that people have built. It's quite a list with all these CLIs. It might be there, so I couldn't hear it straight. But if you add these things, these identifiers, they will be added to your dev container. So there's already plenty out there, and again, you can build your own as well, making them reusable and small units of functionality. Here's one that I wanted to mention because it's inside of every base image that Microsoft has. So it's essentially a clean image from Alpine, Debian, or Ubuntu, and they add this feature to it, which has a lot of tools that you expect in an installation of a distro of Linux. The cool thing is that so it's already added, right? But what it allows you to do is say whether you want to have the Z shell, yes or no. You can just leave it out if it's not your thing. And also it creates this non-privileged user. So this is what is there by default, but you can do that yourself as well. Start with Alpine, for example. Do this and then say the username is Alex and give it a UID and a group ID, and then you can use that inside of your container for reasons, if you have those. This identifier is also the location of the download of the image. So it's in a container registry, the GitHub container registry. It might be mcr.microsoft.com or anywhere else where you store them, like docker.com. You have the user or the org, so that's kind of the repo owner. Then you have the repo, and then you have the feature name and a version. That's how this thing comes together, and that allows it to download the right base image. The right feature. And then you have the properties that you can set. All right, so next thing, we talked about features, then come customizations. So with the customizations, you can say, okay, I have VS Code, but it can be Rider or GitHub Codespaces as well, and I want to do the extensions that we already saw. It can also have its own settings that apply to this DevContainer and or override your local user settings. And the biggest override is obviously your workspace settings. Your .vs Code also has a settings JSON, and that has the highest priority. But you can specify settings inside of your DevContainer JSON definition. So the extensions that you install or how terminals are set up can be influenced with these settings. And you have the MCP section, where you can specify MCP servers that you want to use as part of your dev environment. So I'm just showing an example. The Azure Tools is, again, an extension pack. So it contains 12 extensions. It has this marketplace unique identifier. You can find it on the right column of the website in the marketplace. You can also discover it if you search for extensions. But this unique identifier is put in the section for extensions as a string. And it gives you 12 of these things. You can see the little remote icon because it will get installed remotely in our case. So that's an indication that you see, okay, this is a thing that's being used inside of a container. But the bottom one, it includes an MCP server. So that's nice, right? It's an extension, gives you an MCP service, so you can do @Azure inside of your chat window if you do GitHub Copilot. So that gave me a thing, okay, let's briefly dive into, I want other MCP servers that I use or my company uses, and I want those to have registered inside of my DevContainer as well. So what they do is, we saw the section that was inside of customizations, VS Code, MCP. Whatever is in there is being copied over to the mcp.json, which is your VS Code entry point for finding all the registered MCP servers. Inside, you specify servers. So for example, context 7, maybe you're already using it. You can say, I want to have that inside of my DevContainer because I have some sources there and it will allow me to do better AI-assisted development for Azure. Because @Azure can give me access to my Azure resources, but if I want to have patterns or other things in Bicep Terraform, context 7 might just help you quite well. So you put the things in there that you can just copy-paste by discovering it. But then sometimes it's like, okay, but there's sensitive information, and I don't want to check that in because it's my API key, and if I put that into the DevContainer JSON and check it in, it's there for everyone to see. So that's not what I want. So what you can do is you can say, I have a placeholder with an input, and this input you can define as being, something to ask the user for when this MCP server gets started. So when you start it up, it says, oh, wait a minute, we need to know the API key, and you can paste it in, and it will not show it to you because in this case it says password true, so we will just do asterisks. And then it will show up in your window. All right, last thing, and then we'll just go to the next part. What's important to know is that there's a strictly defined life cycle of your DevContainer. So it starts locally, and you might need to do some prep work before things can get put into work. So it might be you need to generate something on your local machine with your local user rights. I don't know, maybe retrieve a token or whatever. That's something that you could do, or check some prerequisites. Highly privileged, your local user. Then it starts with image creation. This takes some time the first time you do it, but once it's created, it's very fast to start up because it can just start another container based on this image. And if you rebuild it, which you need to do during building up your dev container, it will do the caching pretty well. And then we have an image after that. So on create, you can do some scripts. So these are entry points where you can say, execute this command or execute this script. And you put that inside of your DevContainer JSON. So besides the image, the extension, the customizations and the features, you also have on create command and post create command, which is the things, you pick your moment in the life cycle when you want to do some additional work. This is with the user that's VS Code, for example, the non-privileged user that is running at that moment. Then the DevContainer gets started, you get a post start. It has this VS Code server inside of it. That's the thing it uses to communicate to the inside of the server, which is where the tooling connects to. Rider has their own version, so they have their own Rider server inside of a container. But after attaching, you can also say, okay, then I want to do other stuff, that every time I attach to this container, work gets done. All right, final thing. Since we're in a container, it can't just break out. So if there's ports, you need to specify which ports get opened and visible from outside of the container, and you need to do some work there. It will be automatic, but there's some cool things if you don't do it manually or automatic, but put it in your DevContainer JSON file. So you can say, these are the ports that need to be forwarded. Put that in your DevContainer JSON. That's the additional section that usually goes into the bottom. That will bring out these ports outside of your container, so you can connect to it from the outside in. So you can watch your APIs or things that you have running there. Some things get exposed automatically because you didn't list them. They will get exposed, but it just happens later on. And that works. And you have this section where you can specify additional attributes about your port. So it becomes a little bit more descriptive of what is 3000? I don't know what it is, or 3500. So if you look at your port section in Visual Studio Code, you can see that there's user forwarded, which I did manually, the auto forwarded, which are the ones that I didn't specify, and the ones that I did specify up front. And the names on the left is where you see where I took the effort to specify a name for a particular port. What is this port about? All right. Good. So we did a lot of things, right? I didn't show you the MCP server just yet, but if we go to extensions now, you see that I have this thing installed here, upstash context 7, and if I look at the configuration JSON, and I'll make it a little bit bigger, then you can see that here it has these asterisks, so you don't see the details, right? That's just what happens if you put that in. So MCP servers, we have extensions, we have all the features, the images. We're good to go. We're running this container, and we can step out of this container and reopen the folder locally, and then we drop back to essentially this place where we have all those extensions are gone now. So all these Azure things, AI Foundry, it's all gone. The MCP server is gone, so we're back to a clean machine again, right? All right, I'll stop this one and just destroy it like that. The container is still running, by the way, but I'm not connected to it anymore. And okay, so there were a lot of people that well, sort of fell in between, right? So developers working on things with Azure. So even if you're a platform engineer, you build the platforms and you're like, okay, I'm good to go. I can do Bicep now. I can do all these things and I can work brilliantly. but there's the other team members that also want to do it, not just you. And there's people that are in development teams, and you might be that developer that not just does Azure, but also .NET and React. Maybe you're a full stack developer. So this is a story for everyone. One thing is autonomy. So this has the power to give you autonomy, because if you have DevContainers, there's certainly a way to have a lesser dependency on cloud. Because if you're an app and a cloud developer and you have access to cloud, that's fine. But what if you need cloud all the time and can't live without it? Well, we'll talk about that in a moment. Building up these DevContainers also allows you to give it to others, because it's the definition, DevContainer JSON. If you check it into your code, everybody that opens the code base will get a prompt. We see a DevContainer the definition. Do you want to open this in a DevContainer? And you can just say yes, and everything spins up. So that's good. And you can make that reusable. You can put best practices in there. And you can do those templates and features as well. So it becomes easier to add those things. And that allows to work with this part of development, your environment, also as code, and to automate it from start to finish. Because you can even use, just imagine, this dev environment that we've defined, you can even use that inside of a pipeline. So you can have a clean pipeline, no need to install things in your pipeline, just spin up the DevContainer, and everything inside of the DevContainer is there, ready to build your code and to deploy stuff and do it from there, instead of having to do the installation of a pipeline instead of your machine. So taking it a step further, so you need to pick your tools and put it all together, but once you're up and running, you're like, okay, I have a DevContainer now, there's something in there. The example has .NET, Bicep, and React, and some CLIs, Azure Developer CLI, but that's just an example. I can run this, and if I open up access to Azure, I could maybe connect from my local container into the Azure cloud, which is debatable if that's a smart thing to do, right? Maybe you don't want to do that because you need to open up things, but it's the developer stage, so you could get away with arguing that it's there, but you need it. You have a hard dependency on Azure. So wouldn't it be cool if we said, let's use the DevContainer, and instead of just doing .NET connecting to Azure, why don't we take all these things that we have here? So the example application has a Cosmos DB, it has some app services, it might have a cluster, like Azure Container Applications or AKS. It has a key vault, it has many other things, but what if we move that over to the DevContainer side? So what if we use emulators instead of some of the Azure resources? And what if we use local clusters for Kubernetes? Because all these are Kubernetes based. So I can get a more of a shift left, where I cut my connection to the other side. And if you're a .NET developer, you know that you can do key vault with smart configuration. So you can use user secrets or any other mean of locally having configuration that connects to your emulator and your local cluster instead of the real thing. And now all of a sudden we are doing this full circle development inside of our DevContainer. But we need to put other things in there as well, not just our developer thing, but also all the dependencies that we want to have locally. So how would you do that? Well, we saw for the most part the DevContainer JSON, that's the main configuration file, but you can put other things there as well. So if you start customizing, you probably have a Docker file, but you can also use a Docker Compose file. And I hope that you've used Docker Compose before, but it's a way to compose a set of containers and make them work together. And for each of those containers, you can say use a base image or use a Docker file. So it's a multi-container build thing as well. So you have Docker files for each of your containers, or you just lean on base images. And you have some script files to do configuration work that needs scripting because they need to be done after the fact. They're optional, but we'll start using those in a moment. So the original container connected to our VS Code or other tool, but we want to have more containers with extra stuff. And this is a list of just some examples, but these are pretty common to have as an emulator, right? The service bus, Cosmos DB. You can have SQL Server as well, SQL Server for Linux, which is usually good enough to get rid of your Azure SQL dependency. But you can also have supporting things like SMTP or SFTP servers, Prometheus Grafana, things you need. Just put them in your orchestrated composition with Docker Compose. You'll obviously need to use either Docker or Podman support for that. And the way you do it is instead of specifying your image with a base image, you now specify a Docker Compose file. It can be an array, so if you're using Docker Compose override.yaml or have some layered structure, that works as well. And the Docker Compose file will specify a container that is your main container from which you develop. I've named it DevContainer to make it very obvious that's the one that is listed here as the service to connect to as the DevContainer, but the name may vary. And then you have the Cosmos DB, where you have an image that is available by Microsoft. It could be Azure Service Bus. It has some environment settings. Well, this is all Docker Compose. Go nuts. It works. All right. Now, I wanted to do the demo and show you how you could get rid of for the Cosmos DB, because I have a hard dependency in Cosmos DB, and we have an emulator. But as it turns out, this is the stuff when you prepare, it didn't have an ARM version, and this is an ARM laptop. So if I want to run the Cosmos DB emulator locally, it doesn't work. So I thought, okay, do I get rid of it, or do I go some other way? So you might not have this impediment, so to speak, because you might have a normal x64 laptop, and it would work. But there's also, why are we running this locally? We could run it remotely. So that was my way out, and a nice segue, an excuse to show you code spaces, because I think there's a real potential there. So local, connected locally, that doesn't work for my Cosmos DB emulator. So now I want to move to GitHub Codespaces, not hosted locally, because ARM laptop, no work. So we're going to move this over to Codespaces. And that can connect to Azure. But then the good thing is, I can use a browser to connect to that container and get this browser-based Visual Studio Code experience. You've probably seen it if you press the dot in a GitHub repo, you get the same kind of VS Code.dev. Similar thing, except you're connected to a code space. And you can use the local laptop to use Remote Explorer, but go for one of the other options that was further down the list. That was GitHub Codespaces. You can use the Remote Explorer to connect to that as well. And then it's kind of the same thing. You have this Visual Studio Code server that allows you to connect to it through Visual Studio Code or the browser. But it only has local folders, and it can't do mounts from your laptop into Codespaces. That's just a bit too much. So you don't have the mounts, but you do have the exposed ports. But they do some port forwarding because they are not opening up it directly. It's through this huge URL that's connected to your code space. It is a paid thing, but if you want to try this out, everybody that has a GitHub user account, if you have the free edition, you get 120 hours divided by the number of cores that you spin up. So you say, I want to have 4 cores, for example, that will give you like 30 hours. So a small week. And if you have GitHub Pro, then it's a bit more. But in the end, it's either you with your own account, or your organization paying for this. All right. So let's try to put that all together in a demo and see if we can get it to work. So I'm switching to the main branch. All right. What the main file now shows is the Docker Compose file that we saw before. It still has a lot of things. I also added kubectl, Helm, and Minikube, and the rest is pretty much the same. Then if we go into the Docker Compose, we see the DevContainer, which still uses the image we had before. We're intimately connecting it to the service, so they think they're in the same network. And the Cosmos DB is an image which has some environment settings that you can tweak. And in this case, I'm naming it Cosmos DB, so I can refer to it by the same name as the service. Otherwise, it would think it needs to be localhost, but I want to have it named. But this is Docker Compose stuff, and learning from the docs how you set up a particular emulator with environment variables. Now this will start spinning up, but it turns out that if you want to connect to it and you want to go to, let's first do that. So we'll go here, and I could do reopening container, but that would be locally, and that would give me, emulator doesn't work, no ARM image. So instead, we'll go to code spaces, and there's two ways to do it, showing you briefly. So if you go to your repo, to code, you might have seen this, go to this tab, code spaces, then always click new with options, because you get to configure stuff. And then you can see, you can pick the branch where you want to have your code base, and you can specify the machine type with 4 core, 8 core, or 16 core. There's also a 2 core, but it doesn't show up. And you can specify a region where you want this to be hosted. So take something that is close to you for fastest connectivity. And then you can say create code space, and it will start spinning up. I've already done that, because if you go to GitHub code spaces, you see that on my account, I already have this reimagined acorn. I want to say unicorn, but I got acorn. That thing is already running. So instead of showing you how the container is being built, instead, I will do, and you can even close this. So let's just, for the sake of argument, close this folder, go here, say connect to a code space. There we go. And then in the top, it will say, which one do you want to open? So if I have multiple running, it now says the reimagined acorn, and I say, yes, that's the one. This was already open, so it knows how to switch to it smartly. It does shut it down, so it doesn't keep running if you are inactive. That's good, so you don't burn the hours just by going for lunch. It will shut down, but you can easily start it up again. It will do this setting up. It's kind of nice to see if it's doing it for the first time, you can see all the logs of things that get created. I'm not sure if I can show you now. View creation log. No, we need to wait till this is done. But you can see now that it's, again, the same experience. I'm in my code base again, but now I have all these extra things. So it did add all the extensions. It's running now from code spaces, bottom left corner, and things work. And just to show you how far you can go, if I go into this Azure tool, I can see all the Azure developer things, the API, the web, the environments that we have. This will load probably. But if I go to Cosmos DB accounts, I also have local emulators. It doesn't run now, and sometimes you need to reload the window. So let's quickly do that. But it allows you to connect locally to your emulator, and I can run things from the local setup. So we won't spend too much time here because I have other things to show, but let's see if it now does show the local emulator. No, so that's failed demo, but this works. It worked because, well, it should have worked because we did some things with getting the certificates after creation. So if this is all created, Cosmos DB emulator starts up as a container, and it will give you an endpoint because it's local and it's emulated to download a certificate. And that certificate you can copy to the right place and then update the certified authorities, and then all of a sudden it doesn't give you certificate errors when connecting to it, if it would have worked. You can also say I want to have visibility to ports, and with the thing not working, I can give it a short spin. If I do task, run tasks, and do this run, let's keep our fingers crossed that it might just work locally. So nothing up the sleeves, and it might just not work at the moment. All right, moving on. You see that it's running, but apparently the emulator didn't start. So because I hate failing demos, I will just do rebuild container and do a rebuild. And in the meanwhile, we'll go back to this. So you've spent a lot of time creating this DevContainer JSON with the post create shelf things and put script in there that needs the tweaking to make it all work. How can you make it reusable? Well, that's where templates come in, because templates are about the things to get started. There's a bunch that I put here for just as an overview. Again, Containers Dev has this section. We saw available features, but there's also available templates that allows you to pick your template, and they're parameterized, or there's arguments that you can set for picking versions and then including things, yes, no. So there will be a little survey at the beginning. Do you want to install this? Yes, no. What should be this version? And then you get prompted along the way. The universal one is the one you get for code spaces. So if you don't pick an image, but say, I want to open this code base in code spaces, no DevContainer JSON whatsoever, they will just do universal. And that has a bunch installed, like almost everything, like a Swiss Army knife that probably has what you need. But otherwise, well, I think it's better to create your own one with the correct base image and features. These DevContainer definitions for templates, they are prepackaged, like a zip file, a tarball that is put together. So it's a set of files, but it comes with a definition file that says which options are in there and some description and metadata. So there's existing ones, you can build your own, and I thought it would be cool to show you how you can build your own. The way this works, if you use a template, so that's underwater, if you say, I want to use a template for .NET 8, so you would pick .NET, you get some questions, which version do you want? I want 8. And then it says, okay, I'll download the tarball, and inside of it are those files that are packaged together. They will be unzipped or uncompressed, and they will be added to your DevContainer JSON folder, a DevContainer folder. So it's just a matter of, instead of copying them manually, they will put them in, but there's a little twist to it. It's not just unzipping in the right location. There is some other work done. So it does do transform with arguments during the transformation. So when you want to apply these, an option is to use the CLI. That's one way of doing it, and I've been doing this for a while until I discovered, and I'm not sure, I didn't go back in time, but all of a sudden, I saw this. So it might not have been there before, or they just put it there explicitly. But from the list that they show you with all the templates, you could search in this box, but you can also paste in your own template ID for your own custom templates. And that's cool, because then you don't have to use the developer, so the DevContainer CLI, especially when you get to the arguments, it becomes really tricky. All right, so for the technical bits, if this is if you want to build such a template, and let's demonstrate that first. Maybe that's better. Open a folder. I'll do a quick demo. Azure Dev Summit live. Where's my A? All right. So if I do this and I do add DevContainer configuration files, it says, okay, where do you want to add them? I can add them to my workspace, so that's in my code, so you would see it. You can also keep it outside. If you don't want to pollute it, or there's a reason that it can't be part of your code base, it can be on a well-known location. And there's 2 other locations as well. So here I can say I want to do something with Python, and there's all these templates in a curated list that show up. But you can also do your own GitHub, container registry.io, and then do the identifier, and then press enter, and then it says, okay, I'll use this one. All right, let's pick the one. I have it in my notes here somewhere. Azure Dev Containers, and then it was workload. Oh, just a sec. This is the one. There we go. Okay, I get some questions. So do you want to install and start Minikube? And I'm like, yes, let's do that. And I say, okay. And then what other features do you want? So I can still do additional features besides the one that are already in there, no extras. And do you want these optional files to be copied in? And like, well, let's do that because it's accompanying files. And what it does, it will, and I'll show you how that works. It uses the arguments that were defined in the template, and it will substitute things. For example, in this post create, this true is because I chose yes. So it substituted things throughout the files that are being copied in. And this says, okay, if there, then do minikube and continue. And in the DevContainer JSON, here I can say I want to use it or I don't want to use it. So this would be latest, for example. And then I can spin it up. All right, let's spin it up and see what happens. But the way this works is if you want to define such a template, which we just used, then you would create this structure where you say, oh, this is my template. Ooh, we decided to start building things. So this is the build-up of a DevContainer from scratch, okay? So you put all those things inside of a folder with that is supposed to be your template structure. So the things that you want to have go in there, and you have a DevContainer template JSON that says these are the options that I will feed into the DevContainer JSON. And those options are then, if you want to, transferred as arguments to your Docker file. So there's a nice way to pass options that you defined. Like I have this .NET workload thing because I want to have a generic template that says you can do .NET, you can have a Cosmos DB emulator, you can have Minikube, put it all together and put it in here and say this is what I propose that you can use as the .NET SDK version, for example. If we also saw the install Minikube, yes, no. That's all options. They can be Boolean or they can be string, and that's what you need to work with. But that allows you to do some substitution in all the files and pass arguments for the Docker file. If you wrap this all together, then what you do is you publish such a template and you publish it to a container registry. So even though it's not a container, but it's a tarball, it can be used as a container registry can be used as a location to store these. So we saw most of this. So let me do this final thing that I think puts everything together. So once you have all this running, you can isolate your work, you can make it reusable, you can give it to others. And you have this application that is not there yet, it doesn't use it. So you can do what I showed you today. And this can be a release branch, it can be a tag, whichever versioning strategy that you have. But you can say, okay, this is the one that I branch off because we're going to build a new one. But I still want to have good developer support for this one, so I'll create a DevContainer JSON. And everybody can spin this up, and I have all the tools for ARM templates and SQL Server in a Docker Compose. So, I do a container for SQL Server, local development with .NET 6, old version, but we need to support it. And then the lucky ones, they get to work on the new version. So we create a feature branch, or again, your versioning strategy. And you say, okay, we're switching to Terraform because we'll use that, or Bicep, or whichever thing, Pulumi you have. We'll do .NET 10, we'll use Cosmos DB instead of SQL Server. This is the next version of your application modernized. Again, you'll start probably with defining your DevContainer. So, maybe from a template, because the cloud platform team says, this is how we can give you a quick starting point. But this will give you all the tools like we saw before, and then you can get started from there. So you'll do work there, maybe there's some work on the main branch. Then you'll probably synchronize, and finally you'll do a pull request. And somebody can open up this branch, and because it's a DevContainer, they can just, if they have Docker support and they have Visual Studio Code with the Remote Explorer, they can just say, open in container, and it will start working like I showed you. But then it merges back to the main branch, and then all of a sudden the main branch is on version 2, and we can work If we're here on the main branch, we can use this tooling. If we switch branches back to the old 1.1 version, we get that container, DevContainer JSON, and if we spin it up in a container, we get a different container with different customizations, extensions, and settings. So, you can quickly switch back and forth. And if you want to go all nuts, you can even have subfolders in the .devcontainer folder that allows you to have multiple DevContainer definition inside of a single version. So you can say, this is the front-end developer, this is the back-end developer, this is the platform engineer thing that has their own tooling. All right. So I think we're out of time, but I hope that I showed you and I got you enthusiastic about how you can use Azure. You need the tools, frameworks, and the dependencies, the runtimes, put them in a container with a tool, and we focused on Visual Studio Code, but other tools can be done as well. You can have connectivity to those containers, which as code allows you to work versioned, get up to speed pretty fast, and make it reusable with templates and features. And then finally, didn't show it, but you can also have dot files. Dot files are supported. So if you know dot files for Linux, they are copied in from your repo that you point to, and they do symbolic linking, so it works. So you just say, this is my dot files repository, and all of a sudden, it all lights up. DevContainers, they love Azure, and I hope you love DevContainers. And that's it for now. So thank you very much.